Well, good afternoon, and thanks for joining this session today. We will see how to boost productivity thanks to new generative AI and scalable development tools that run in Jupyter notebooks from anywhere. My name is Giuseppe Angelo Porcelli. I'm a machine learning solution architect at Amazon Web Services. So let's quickly go through the agenda for today. We will start with Jupyter and AWS, our vision and the innovations. Then we will talk about the new extensions that you can use from anywhere Jupyter runs. And then we will see how to get started in the cloud with AWS to learn and experiment ML for free. And finally, how to advance your machine learning development with Amazon SageMaker. We will save some time for a quick demo as well, and hopefully Q&A at the end of the session. So Jupyter notebooks are ubiquitous in data science, machine learning, and scientific computing. Data workers, such as data scientists or data engineers, researchers, they love using Jupyter notebooks to tell stories using a mix of markdown, code, visualizations. So they also love notebooks to select among the hundreds of kernels that are available and use virtually any programming language. What we see here in these stats is just some indication of the popularity that Jupyter notebooks are gaining. So in the past 5 years, we can see from 2015 to 2022 how the number of notebooks available on GitHub has increased. It's pretty massive. And then on the right-hand side of the slide, we see in the State of Machine Learning and Data Science survey published by Kaggle in 2021, we can see that Jupyter Lab still continues to be the preferred interface for more than 70% of data practitioners. So our vision at AWS is that we believe that ML is one of the most transformative technologies nowadays. So we want to make machine learning accessible to every learner, developer, and data scientist. And well, this is not a new goal for us. To date, we have trained 140K developers for 150 different countries using DeepRacer. In 2021, we have trained over 1 million people online with courses like Dive into Deep Learning, DML Universities, training and certification initiatives. And as you can see, this is significant investment, not only on the services side, but also on enablement and education. But if we move on the technology side, given the importance of Jupyter to data scientists and machine learning developers and practitioners, AWS is an active sponsor and contributor to Project Jupyter. Our goal is indeed to help Jupyter to be the best possible notebook platform for data science and machine learning. And here you can see all the innovations that we have introduced in the notebooks on AWS. We started in 2017 with SageMaker notebook instances when SageMaker was launched, which are fully managed notebooks that are running in the cloud. You can easily spin up and manage the notebook and get access through the web, through your browser. You can get access to the managed notebook. You can change compute resources. You don't have to worry about managing the underlying infrastructure. All of that is done by AWS. Then in 2019, we launched the SageMaker Studio, which is the first fully managed IDE for machine learning. And even Studio is based on Jupyter Lab. And from Studio, you can actually implement all the steps of a typical machine learning and data engineering workflow, which start from the data gathering, data analysis, and then building models, training models, deploying models, monitoring these models after they have been deployed, detecting bias, a lot of features, a lot of capabilities that are accessible through SageMaker and SageMaker Studio. Then in 2021, we wanted to further extend the benefits of SageMaker to the community of millions of Jupyter users by launching Amazon SageMaker Studio Lab, which is a free notebook service that includes even a free GPU for you to use. So you can just sign up to Studio Lab and use free notebooks hosted in the cloud. You can get CPU, GPU sessions, and you can just start working on these notebooks. In 2022, we have continued to evolve the notebook experience in SageMaker Studio, adding a number of capabilities to bring data engineers as well in the same, let's say, IDE, so integrating with remote clusters for running Spark workloads, integrating with enabling features for real-time collaboration, a number of innovations, again, in 2022. And finally, in 2023, today, I'm happy to really announce new innovations that we are introducing, new tools for data science, machine learning, and scientific computing. All these tools you can install today and use from anywhere Jupyter runs, and they fall into two categories: generative AI tools, so the Amazon Code Whisperer Jupyter extension, the Jupyter AI project, and then on tooling for scaling your machine learning development, we have the notebook scheduling extension and the SageMaker distribution. Let's go into the detail. Jupyter AI is an open source project that we are launching today, that we are announcing today, to bring advanced generative AI features to Jupyter notebooks. You can use the power of large language models like OpenAI models, AI-21, Jurassic 2, for example, and the coming soon Amazon Titan models. For example, using these large language models, Jupyter AI can help a programmer to generate code, to analyze code, to debug, to optimize their source code. It's very easy to use. You can just pip install Jupyter AI in your notebook environment, and then you can configure the model provider that you want to use to interact with the large language models. And after that, you can just use the magics, the Jupyter AI magics into your notebooks to generate the code and to interact with these models. At the same time, you have a side panel that you can see here on the right in the screen, where you can interact with the chat-based interface with the models. And for example, you can select a portion of code as shown here in this example and ask the model to explain what that code is doing. Jupyter AI as well provides integration points that allow third parties to provide their own models. You can use models, for example, from Hugging Face Hub, and you can use models that are hosted as well on SageMaker endpoints. Great. Again, Amazon Code Whisperer is an AI coding companion. It's a service that we have launched that allows you to generate real-time, single-line, or full-function code suggestions for multiple programming languages. What I'm happy to announce today is the availability of the Amazon Code Whisperer Jupyter extension that runs in Jupyter Lab and in SageMaker Studio. With Code Whisperer, you can write a comment in natural language that outlines, for example, a task that you want to do, like, hey, create a pandas data frame using a CSV file. And based on this information, Code Whisperer recommends the code snippets and injects the code snippets directly into your notebook. You can choose to keep that suggestion, skip the suggestion, look at next suggestion. All of that is available thanks to this extension. If we move on the side of the tooling that helps scaling your development, what we have seen is that data workers and machine learning practitioners typically want to, when they want to productionize their code, they either extract the code that is available in the Jupyter notebook and restructure that code in the form of a Python script that then needs to be orchestrated through some tooling like workflow orchestration tools, or even using CI/CD tooling to execute some automations and bring this code from the Jupyter environment to a production environment. Well, this is quite a significant effort. You can think about all the infrastructure that needs to be set up to do this kind of task. So a very convenient path is to just, hey, why don't I just execute the notebook as it is? And what we are indeed doing is we have enabled a new extension that allows you to do notebook scheduling. So you can just install this extension in your Jupyter environment, and then you can say, hey, this is the notebook that I want to run on a schedule or that I want to run on demand. And you will select the infrastructure that you want to use for that, and the extension will make sure to package your notebook and run as a job. So we'll execute this notebook as a job. This is using behind the scenes SageMaker jobs, SageMaker training jobs. And well, at the end of the job, the SageMaker infrastructure will be terminated automatically, and you will get back your results from the execution of the notebook. Another challenge that we have seen frequently when talking to practitioners is that while experimenting in their notebooks, they typically want to use different libraries, even when coming to machine learning and working with PyTorch, for example, as a framework. Then at some point, I might want to switch to a different library. I want to use TensorFlow. What I need to do is then, okay, make sure that I can install this library, make sure that the libraries that I have in my environment are compatible, that I need to manage the compatibility between the various libraries. And well, this is a pretty significant effort to keep in sync, let's say, all the library versions and all the packages. So what we are launching today is the SageMaker distribution. SageMaker distribution is a new open source distribution that supports the most popular libraries and mutually compatible packages for you to experiment, for you to practice within Jupyter. So the SageMaker distribution comes into the form of a Docker container. You can check in our documentation on how to pull this Docker container from the public ECR gallery repository. And you can run this container on your local machine. Jupyter Lab is installed in this container. You can run this container on your local machine, work with the SageMaker distribution, and then maybe when ready, when you want to use cloud instances and you want to move to SageMaker, you can keep the environment the same. This is a pretty good tooling because most of the times when you have to move from your local environment to a cloud environment, you need to make sure that the libraries and the environment where you are developing are consistent in the transition. And the SageMaker distribution not only works for interactive development, so when you move to the cloud and when you work in SageMaker, you can attach the distribution to SageMaker Studio and work with the same distribution, same runtime. But as well as when you transition from interactive to job, the SageMaker distribution, the same container, can be used to run as a job. So you can easily see how this streamlines your development process and reduces the friction that are introduced in transitioning from one step to the other. Another thing is that the SageMaker distribution comes also as a cond environment specification. In case you don't want to use Docker, you can just generate a cond environment based on the specification of the SageMaker distribution that you can find on GitHub. Great. We have seen these innovations that, again, are available today, are open source, and can be run anywhere Jupyter runs. They are not only related, let's say, to cloud and to SageMaker. But when is the right time, to move from a local environment to the cloud? Well, there are several motivations for doing that. First of all, you might want to use a fully managed environment, a secure environment, fully managed. I don't have to worry about managing the infrastructure. I just want, delegate this task to the cloud provider and then make sure that I focus only on my core activities, which are indeed, my core business, working on my projects. Then another good reason is that you might want to scale your compute resources. Let's say I want to use GPU instances for a task. I might not have a GPU available locally, or I want to run distributed job. I want to run a distributed job. I need multiple instances to be orchestrated. Then, well, that's another very good reason. I want to use the additional tooling that are available in the cloud for machine learning, like in SageMaker, where we will see there's a lot of tools that address the various stages of the machine learning workflow and enable as well collaboration. So you might have a team that wants to work on a project, and you want to enable collaboration for the entire team. And in general, you want to reduce the time that is required, to get to a result, which could be training time, data processing time, depending on the type of task they're trying to address. Well, in this transition, when you start using the cloud, what you can start with is looking at Amazon SageMaker Studio Lab. SageMaker Studio Lab, as I said, is a free environment. You can just create an account with an email address. It's free. No setup, no configuration is required. You immediately get access to Jupyter Lab running in the cloud. You have 15 gigabytes of storage to save your projects. These are persisted even when the instances, let's say, are terminated. And you have as many compute sessions as you need, which are in 12 hours CPU compute sessions, and GPU sessions take 4 hours, are available for in 4 hour sessions. And then you get integration with GitHub, so you can easily connect to GitHub repositories, and you can choose to migrate to SageMaker Studio. There's a transition path from the Studio Lab, from the free environment to SageMaker Studio, which is very easy to follow. And if you're interested, you can just use the referral code that you see here on the slide to get immediate access to SageMaker Studio Lab. Great. Next thing is, once you move to more, when you work in your enterprise and you want to leverage on the full set of capabilities that Amazon SageMaker offers, you can then look at Amazon SageMaker Studio. SageMaker Studio is a web-based IDE that addresses, as I said, all the stages of the machine learning workflow, as you can see in the picture, from data prep to model training, running training jobs, data processing jobs. You can host your models on a fully managed infrastructure and deploy your models as real-time endpoints. You can then explain your inference, do explainability. You can do bias detection. There are a number of features for data and machine learning practitioners available in SageMaker Studio. And SageMaker Studio itself, the notebook experience that is available in SageMaker Studio is based indeed on Jupyter Lab as well, as you can see from this slide. You get in the Studio Notebook experience, you get access to features like the ability to do single sign-on into the notebook. You can easily switch the compute resources. The Studio architecture uses a remote kernel architecture, so the Jupyter server is running on one instance versus the kernels are running Dockerized in Docker container on separate instances, and this gives you the chance to say, hey, for this notebook, I want to connect this notebook to this kernel that is using, for example, GPU compute resources, and then I have another notebook that I connect to another kernel that is running on a different compute resources. This is possible. You have a lot of flexibility in Studio. You can easily switch the instance type there. You get collaborative features like real-time collaboration within the context on what is called a SageMaker space. You get, for sure, integration with Git repositories and the ability to share notebooks, all these collaborative features. As I mentioned earlier, you get integration with several additional AWS services which allow you, for example, to connect to a Spark cluster through the Amazon EMR service from your notebook and run interactive data exploration with this remote cluster with distributed Spark available in your notebook. Then you can do things like running serverless interactive sessions from your notebook to access distributed Spark or Ray in a serverless mode, so without having a cluster up and running and with the serverless pricing model. And the other great thing is that Studio is fully customizable. When you work in Studio, it's fully customizable. As I said, the kernels, the runtime for your notebook is based on is all based on Docker containers. So you can use the containers that AWS has developed, and most of them, by the way, are open source, and you can find the implementation on GitHub, or you can bring your own container. So nothing prevents you from packaging your own Docker container and attaching to SageMaker Studio to have your baseline configuration of libraries that you might want to use in your company. And in the context of Studio, I'm really happy to, and SageMaker in general, really happy to announce today a capability that allows you to accelerate local machine learning code conversion to training jobs. So similarly to the problem that I was referring to earlier, when we have seen the ability to schedule a notebook job. So when you have code in your notebook and then you want to transition to a batch infrastructure and run as a job, in this case we're not scheduling the execution of the job, of the notebook, but we are basically decorating a standard Python function that is implemented in your notebook with a decorator, the so-called remote decorator that you see there in the screenshot. And this decorator will take care of packaging the function and the related dependencies and making sure and transitioning that code to run on the job infrastructure really seamlessly without any specific intervention, without any extra coding required. All of that is done behind the scenes, and you just need to. So the nice thing is that you can keep your code as it is. You don't have to apply any modification to your standard code, function code. It's just pure Python code, and you just decorate the function to run as a job. There's a clear separation between infrastructure and, so let's say, the orchestration and the actual code, the actual business logic. Great. Let me go through a quick demo. The focus of this demo is to show you the SageMaker distribution and then how to transition to jobs. So exactly this feature that I was mentioning. For the Jupyter AI and for the notebook scheduling extension, there are dedicated sessions at the JupyterCon, as you have seen in the slide, that in case you want to dive deep, you can join these sessions. And let me go to the, just need to duplicate my display. 1 sec. Should work. Good. So here we go. Let me. Okay, so as you can see, this is where the SageMaker distribution is published on GitHub. And as I said, here you find instructions on how to pull this Docker container, how to run the Docker container locally. JupyterLab is installed in this Docker container, so you can run JupyterLab as well. And if you look at the build artifacts folder, you can see in the env.out file, you will see exactly all the packages that we are including in the SageMaker distribution with the specific versions. And this allows you also to recreate a code environment if needed. So what I have done is I have pulled the SageMaker distribution on my, as you can see here, on my machine. And what I'm going to do is just running the SageMaker distribution quickly, running this container quickly, and starting JupyterLab. So this gives me access to JupyterLab. Let me copy and paste this URL, and then I can go to my local JupyterLab. Okay, so this is my local JupyterLab, and I have mounted to this Docker container a folder with some example code, and I have this example notebook that trains a very basic model using PyTorch. It's the the standard handwritten digit recognition model from MNIST. Regardless of the details of, let's say, the data science aspects of this example, what you can see here is that I don't have to install any specific library. I can immediately get access to Torch Vision, to all the PyTorch libraries without any problem, are all available in the SageMaker distribution. This is the definition of the neural network, plus a couple of utility functions to run training and checking, evaluating the performance of this model. And the other thing that I can do easily, I can, I don't know, do things like import XGBoost, and XGBoost is available as well. I can import TensorFlow, so I don't have to worry about you know, changing the installing extra libraries. All of that is available in the distribution by default. Then okay, let's train quickly this model locally. It's a dry run. It will train just for a few, just for one epoch. It's a partial training just to make it faster. And yeah, as you can see here as well, this is the version. You can check the versions of the libraries that are available, and then you can, you know, experiment locally in your notebook. So now, when it's time, you know, to transition to SageMaker, what you can do is, I am in the SageMaker. This is the SageMaker console, and this is where you configure the SageMaker Studio environment. And in the environment section here, I have attached the SageMaker distribution to SageMaker Studio. So I'm saying, hey, I want you know, Studio notebooks to use this container image to run kernels. It's exactly the same image, the same container. And then when I move to SageMaker Studio, you can see indeed that I have, hopefully, let me see if I can zoom in a little bit. You can see that I have the SageMaker distribution here running. This is the image that I'm using, SageMaker distribution. And then you can choose a distance type that you want to use to run this container and to run your kernels. And, well, it's already running. I don't have to do that. But as you can see, exactly the same code that I was running on my local notebook using the container running locally can be run in SageMaker Studio without any modification. And yeah, we can run this cell if we want. What I want to show you now is how to run that code as a job. Suppose that I want to use different compute resources now to run this function, the perform train function, and I want to execute that code as a job. The only thing that I need to do is adding this decorator to the function, the remote decorator to the function. There is a parameter here to keep alive the training cluster. It's just a extra configuration that I have added, but it's not a mandatory parameter. Then you can execute this function, and if I go, okay, here I'm just installing the SageMaker libraries here, and if I go to the perform train operation, now what will happen is that, as you can see, the same function, the perform train function, is not running locally anymore, but it is running as a SageMaker job, has been moved to separate infrastructure that is using separate compute resources, and it's running as a job. So now we are waiting for the function to be executed. As you can see, there is a starting training job operation that will produce what you see here, the trained model. The result from the function, we also take care of the deserialization of the results so that you get a standard Python object as output from the job. So after the job is completed, you get back the object that the function returns. So that's the way it works. As you can see now, the function is being executed. There is a, well, again, it's just one step here running for a short period of time. And after the function completes, hopefully soon, it will take a few other seconds, we can get access again to the trained model object within the notebook. So even if we are using separate infrastructure that we can monitor, by the way, using this screen here, training jobs, if I refresh this screen in SageMaker, I have indeed, this is the execution that we have run right now. And the function is completed. It gives you indication of how much you're going to be billed for this execution of this job, 42 seconds of that infrastructure. And then you get access to the mod, back to the mod. So the result of the execution as a job is still available in your notebook. Great. The last thing that I wanted to show you is that this concept of remote function does not only apply to machine learning, it applies to any kind of computation that you might want to execute in your notebook. Indeed, what I can do, I can say, create a function to compute the factorial, a function to compute the factorial of a number iteratively. And the nice thing is that def compute factorial is that I'm using the Code Whisperer extension that is running in my notebook to create this function. So this is the this is the Code Whisperer extension that is running in my notebook. I've done some mess here, but well, sorry. This is the Code Whisperer extension that is running in my notebook. I have installed and running in my notebook. And I can do result equals compute factorial, print result. And as you can see, okay, this is, for some reason, is not working. There's no return in the functions. Great one. Return result. Sorry. It computed the factorial, and then last one is if I do remote, the remote decorator. Now this function will run as a job. So imagine if you have a complex compute operation that has to be run in your function, your notebook is not enough to run that function in terms of compute resources, you can just decorate your function and run as a job. Okay. So that concludes the demo. We have, I think, 1 minute for Q&A, but in general, I will be here around at the AWS booth for the whole day in case you have questions, so feel free to reach out to me at the booth. Thank you.